This is another report brought to you by Dmitry Ursegov from Arena Data. It will be on Greenplum, the very first on Greenplum this year. So not exactly about Greenplum, but there will be some information about Greenplum for sure. So hi everyone, I am Dmitry Ursegov from Arena Data. We deal with a data platform, and one of the services we use is Greenplum. It is an analytical DBMS based on PostgreSQL, and in such system we have to work with large amounts of data, and I will tell you about our approaches, and I will tell you about how to connect Greenplum and Greenhouse and ClickHouse. So in analytical systems, we work not on specific rows, but on large amount of data. Most of times it's filtering, aggregation, and some manipulations on columns. That's why such systems have column storage. It should be a distributed cluster because data are so numerous. They must be processed, and their focus is to optimize throughput, not response time. And indexes do not help you in such systems because you just have to go for a column and do something with it. As far as Greenplum is concerned, this is a distributed system too, and there is some Postgres in Greenplum nodes. There is one master that controls how cluster works and how it collects data from nodes, and segments that store data and perform most of calculations. Master can do some additional aggregations, but most of time it is done by segments. And as far as this task is concerned, work with external data, there are common tasks, and it is very convenient to work with external systems, and it's better to represent them as a table so you could make standard queries. And there are particular tasks like to get data completely from external database, and you can do it by using common way. Sometimes it is difficult, but you can use frameworks instead, and I will tell you about it later on. You can use them for external and for foreign tables, and you can represent it just like a Greenplum table and keep on working with it. So I started to enumerate the main approaches in Greenplum, frameworks, and for them you can write your own protocol, or you can use existing ones. The most popular ones are GPFDist and PXF. If you work with Greenplum, you must be aware of them, and I will tell you what it's all about later on. And apart from these frameworks, for external systems, you can write a specialized extension that can do whatever it is required to call for external data. What is GPFDist? If there is an ETL host that holds text files, and you have to put these text files into our distributed system, you can use GPFDist for this. And you can write a protocol for external tables in order to work with this and in order to upload data to our system. Then there is a PXF, Platform Extension Framework. It's a dedicated Java service. It is used to call Java services. It means that there are some systems written on Java like Hadoop. They got Java API. There is no need to go from C-based Greenplum and to change something in this code to talk to such systems. It's better than just to have a dedicated service that works with them. through Java API. So for this kind of operations, you can use PXF, and you can write your own module just to support such systems. You can talk to such systems not only through Java API, but through other APIs too. This PXF is used as a one extension for all segments, and if we take a closer look, you can find flows for all segments, and these flows capture data from different segments and they feed them to external services, or they can do it vice versa. Everything is done concurrently, and also you can leverage different other protocols. When it comes to FDW in Greenplum, such option exists. In Postgres, everyone is aware of it. It appeared in version 6. There is no full support, so there is read from all segments, but write operations are executed through master. Only Postgres Planner scheduler is supported. Standard extensions still keep on working with foreign tables framework, so it's like in version 7 we are going to get rid of this external table support. So when it comes to specialized extension, it can be any type of code. There are different approaches that I saw in other extensions. Most of the time they are using a more complicated logics for external tables, so it's not like one external table and there are some selects. It's a logic that creates external tables, deletes something, selects something, and you can use, for instance, something for data transformation. You can also use additional process like with PXF. If you have a Java services or systems, you've got some complicated API for them, you can use external processes not to put all this logic into Greenplum. And a third option is to connect to segments directly. Because it's just a Postgres instance, there is no problem with it. There could be problems with consistency, so try to be accurate. But this is not a recommended approach. Next, I want to tell you how to develop a connector from Greenplum to ClickHouse. First, a few words about this connector. Greenplum is designed to build big data storages. From sources to data marts, it has all necessary functionalities, syntax, big data connection support, NCSQL, distributed transactions. But there are some things that are better implemented in ClickHouse, like you got a connection, you got a data mart which is big, and you make some analytics on it. So ClickHouse is faster than Greenplum because their engine is quite efficient. It works at least 10 times faster than Greenplum, so no competitor so far. That is why there is some sense to get your data and to put them into ClickHouse. When you develop a connector, you have to pay special attention to three main areas, which are architecture. So one of the approaches that I mentioned are performance and consistency. And now let's take a closer look at all these areas. We're going to use this example with our connector, how we tackle to these areas. So architecture depends a lot on the system that we work with. When it comes to ClickHouse, it has some special features that you can insert big blocks with limited frequency and concurrency of queries, and the speed of insert is up to 200 megabytes per second. One of the requirements was to regulate somehow the speed, so we can use smaller. If, for example, we use smaller batches, ClickHouse couldn't handle it. The first approach was to insert segments, insert data directly. It was okay, but still we were not able to control the speed of such operations because there was no synchronization option. That is why we decided to use PXF module, because it keeps all data from all segments in one process, and this is how we can control transfer speed. So this is just an example of architecture, a simplified version. So Greenplum serializes rows, and then it sends them up to streams, to flows. They run inside the PXF module. These rows go to buffers. They are added to a queue, and also we have network flows to calculate these threads, and then they are sent to ClickHouse. And also, it is to be noted that you can get something from ClickHouse. It is the send operation result. Sometimes you can come across an error, but this system is easily configurable, so you can modify queue size, number of streams, and so on. So you know your clusters, and you can just tune your system according to your parameters, so it works correctly. But also there is a fine-tuning mechanism to make your life easier. Once the architecture is designed, is written, when the code is ready, you can expect some level of performance, and you can expect some load on the system. But reality is a little bit different. And I want to tell you about 2 reasons why it happens in our case. It was a configuration error. We've noticed it through top and other network monitoring tools. It happened that CPU cores load wasn't equal, and the network traffic that is generated on Greenplum is higher than it gets to ClickHouse. So obviously there was something wrong. Eventually, these external tables that we work with using PXF have their distribution keys, and they should match with the table, with the distribution keys of our table. So some maybe very simple things, but you can track them down by looking at the load profile. Next thing, since this tool is just puts the data, it can convert them. You can use perf for Postgres, async profiler for Java services, PXF in our case. You can visualize it somehow through flame graphs. Maybe these are obvious things, but you can see how many times data is copied. And if something looks weird, you have to pay special attention to it. With PXF, there was an unnecessary conversion. We deleted it and saved some resources. The speed was 15 megabytes per second per segment. It was okay. On the host, there were around 20-30 segments, so we could give away some megabytes, and the overhead for PXF was around 20%, which was acceptable for us. And by the way, the architecture was clear for us. We didn't have to go to Greenplum and to make some synchronization. So there was no need to make our architecture more difficult. Apart from this, you can remove PXF, but the logic will become more difficult. Maybe in future. And it looks very natural since we have a column shared both in ClickHouse and Greenplum. We can avoid serializing data and just feed columns. When will it happen? I don't know. Maybe we will have not 15 megabytes per second, but 50 megabytes per second if ClickHouse will be able to handle such load. Aspect 3 is consistency. In this case, consistency should be implemented between Greenplum and ClickHouse, and since we have no distributed transactions for external or foreign tables, there are no transactions in ClickHouse. It creates a difficulty. You can bypass it, so we can emulate, we can simulate a transaction since we have no real transactions in ClickHouse. We copy an intermediate layer into ClickHouse, and it should have the same topology. We check the number of strings. We can switch pieces of data by ClickHouse means without copying, and by doing so we can make sure that everything is okay. If something breaks up in the middle, we have additional features in our extension to fix these temporary tables. When we switch these pieces of data, something wrong can happen, but we're trying to minimize these problems. So my presentation was short enough because I had only 20 minutes, and the conclusions are the following. If you write any extensions to work with external data, consider using FDW. It is easier because Postgres knows how to work with FDW. PXF module is worth using if you have external services, or you are using Java services, or you have Java-based client. As far as speed is concerned, Postgres instance can get data at the speed of 15 megabytes per second. At least it was our result. And overhead using PXF is 20% if you're not doing any additional conversions. So if the load is 800%, PXF will get around 150%. Ongoing optimization in this area requires a lot of efforts. It's about synchronization among segments, or you can get an error. So it's not trivial just to take something and accelerate it. And also you can get support for normal transactions with some tricks. And I already mentioned this. And that's it from my side. Looks like I made it. I said within time frames. Thank you very much. We've got 3 minutes for questions. Everything clear? And you can repeat what has been said? Okay, thank you.